Hi, welcome to this lesson. So to start with, before we get onto the main topic, I want you to try these questions. If you can't remember how to deal with the first one, then watch on and then try the second one yourself. So make sure you're testing yourself on a topic from a while ago. Well, this is known as a quadratic on the left, a quadratic expression, and it's equal to 0, which makes it a quadratic equation. And to factorize means to put into brackets and then we're being asked to solve as well. So what we do, I'm not going to go through the whole process, but we're going to need double brackets here because of the way it's structured. I'm going to set that equal to 0. The only way we're going to get x squared is if I put an x there and an x there. I then need two numbers that multiply to give minus 6 and add to give minus 1. So one's going to be positive and one's going to be negative. So it's just a case of trying some values. 1 and 6 aren't going to work. Those are a pair of factors of 6. So let's try 3 and 2. And then I can see if I make it minus 3 and plus 2, then it will work. Because when I do my cross multiplication, I'll get 2x, I'll get minus 3x, that will give me minus 1x, and I'll get my minus 6 from this multiplication. What we then do is we say the whole point of it being equal to 0 is that we can then use the idea that if AB is equal to 0, then either A equals 0 or B equals 0, or both in this case, in fact, because you can't have 5 times a number equals 0 unless that number is 0. So it must be that x minus 3 equals 0 or x plus 2 equals 0. And then we can just, sorry, that was meant to be a minus, we can then just solve these equations to give x equals 3 or x equals minus 2. And over time, you learn to just switch the sign, essentially, from what it says here. But I've gone through it in more detail. I've just tried to remind you why this process works. On to the second one then. So very similar setup. We're going to need to factorize it in double brackets, set it equal to 0. We must have an x and an x. Two numbers that multiply to give 3 and add to give minus 4. Because this is a plus 3 and this is a minus 4, they've got to both be negative. That's the only way I can get a negative here, but a positive here. And actually the only option, if it's going to be nice whole numbers, is going to be 3 and 1. You could, of course, have it the other way around, x minus 1, x minus 3. It's the same thing. And then we jump straight to the solution, x equals 3 or 1. I'm hoping you're happy with this little recap. It's a good reminder because it's actually going to underpin what we're doing today. Right, I'm just going to erase this actually because I'm going to need this space in a minute. Okay, we're going to look at one other set of equations. Here we go. More quadratics, but this time I want you to solve them using the quadratic formula, giving you answers to 3 significant figures. If you can remember how to do that. Okay, well here's the quadratic formula. It's, first of all, it's if ax squared plus bx plus c equals 0, this gives us the solution x equals minus b plus or minus b squared minus 4ac square rooted over 2a. Now this formula doesn't just come out of thin air, it actually comes from taking this equation at the top and completing the square and solving it that way. That's not something I'm going to do today, but we actually mathematically can prove this formula, something I've done previously. As for now, we just need to be able to substitute the values in. That's the main thing. So I've got my equation here. I've actually got a 1 here, so I can see that a is going to equal 1, b is going to equal 5, and c is going to equal minus 4. So I could just substitute those values directly in. X is going to equal minus 5 plus or minus 5 squared minus 4 times 1 times minus 4 square rooted, all divided by 2. And what I would do is I would write that down, but then just put it directly into your calculator. Start with the fraction button, -5. We can't really I don't think we can do a plus and a minus on a calculator, but so let's start with plus. Okay, just write exactly the same thing in really carefully. And we get our first answer. Now it's a surd, so actually you can factorize in theory, but it'll be a surd coming on there. But because we're working to 3 significant figures, in an exam I'd ask you to write down maybe 5 figures, but I'm going to go straight there today and just round it straight away. So 0.702. And then my other one, I need to do minus, and I get minus 5.70. Okay, so this actual topic comes up right at the end of a higher tier GCSE paper, but if you can learn the formula and practice substituting it in, it's actually not as bad as some of the other questions that will be later on, in my opinion anyway. Right, second one. Do have a go at it. I'm going to go for it now. This one's a little bit sneakier. We just need to be careful. I still get a equals 1, but now I get b is -3 and c is equal to 1. So when I solve it, this is what I get. It's actually going to be -3, so I'm just going to write +3. But this is the point at which the most common mistake occurs. You are not doing -3 squared, you are doing -3 all squared. So you should always put a bracket around that -3. If you write -3 squared, it will come out as -9, and that's not what you want. So key point here, put a bracket around it when you have a minus like that. Then it's going to be -4 times 1 times 1. You can actually take shortcuts because 4 times 1 times 1 is actually just 4. So you don't even need to put that bit into your calculator. But you can if you like, if you just want a set method that will work. And then we're still divided by 2 in this case. And another like way of avoiding the -3 in brackets issue is just to recognize that it's going to be a positive, and you could just actually do 3 squared, but maybe we should just be careful. Okay, and I get 2.62. Or 0.382. Now, I'm just going to make one final comment. I've used up most of my space here, but I just want to actually remind you or tell you, if you didn't know previously, what these solutions actually represent. If we look at the one on the left, then what they're actually telling me is where the graph crosses the x-axis. So I know it's going to cross at 3 and at -2. And if you understand what quadratic looks like, it actually also tells you the shape. So my quadratic y equals x squared minus x minus 6 will look like this. It will go through the axes at -6 because that's when x is 0. It will go through, sorry, that's the y-axis, and then it will go for the x-axis at these solutions here. So solving quadratic equations is really powerful, and it tells you a lot more than you might first think. You might just think I'm just solving an equation, but it has some geometrical meaning as well. Anyway, I hope you're happy with that. Solving by factorizing and solving using the quadratic formula. So we've looked at solving some quadratic equations, first by factorizing and using the quadratic formula. We'll see how this comes in today. Because today we're going to actually be solving simultaneous equations involving quadratics. So not just a quadratic by itself, but simultaneous equations. Previously, you've solved linear simultaneous equations, so basically when you don't have an x squared term in there, something like x plus y equals 3, and maybe x minus y equals 7. We can use the process of elimination for that. We could actually use something called substitution as well, but the way I tend to teach it is to use elimination add. Because there's plus and minus, you could add the two equations together here. It's not going to quite work in the same way here because of this x squared term. We're actually going to develop a different approach. But before we do that, I just want to recap the idea of simultaneous equations, what's actually going on when you solve it. And this is what is going on. So these curves here, the red one is actually y equals 2x minus 1. It's a straight line. It has an intercept of -1. It's got a gradient of 2. That's what we get. The blue one, it's harder to understand where one's come from, but the blue one is this quadratic. Okay, it's a smiley quadratic. It's got an x squared term in it rather than a minus x squared. I'm not going to go into any more detail about the shape of the curve. However, the main point of this graph is to say that what I'm trying to find when I solve these equations are these points here, the points at which the graphs intersect. They are the solutions to the simultaneous equations, because when x equals 1, I get y equals 1 in both equations, and that's what I mean by a solution. This graph, although you wouldn't be given this graph in such a question, it helps also give an idea of how we go about solving these equations. Because I can see that where they cross, if we just focus on this one for a minute, where they cross, the x and the y values on the equations are the same. I've just been speaking about that. So that means that this value here is equal to this value here. What we can actually do is we can therefore just set them equal to one another, but essentially set the x parts equal to one another. So 2x minus 1 is equal to x squared minus 2x plus 2. That is our first step for solving this problem. So what I've managed to do, again, is eliminate the y from the problem. And it makes sense to eliminate the y here because it's the thing on the left that's it's just there by itself. Now we've got an equation in terms of x that we can solve. All right, the next step, I would advise you to get the x squared on the other side. So I'm just going to flip the left and the right hand side around. And then we're back into trying to solve a quadratic equation, but this time it's not equal to 0. There's an extra steps we need to do to make it equal to 0. What I can do is I can minus 2x on both sides, and I can add 1 to both sides. So I've managed to make a quadratic equation equal to 0. And if you compare it with the one above, actually it's the one that I got you to do second time around on factorizing. So if we can factorize, if you can remember how to factorize, we're well on our way to being able to solve this problem. Okay, we factorize it, and we're going to get x equals 1 or 3. Now, this part here was what we did at the start, so you can see today there's a little bit more because we have to do these extra parts first, and then we're not actually quite done. Because, like I said, we're trying to find where the graphs intersect. We've only found the x values. So just like in simultaneous equations that are linear, we need to actually find the y value as well. When x equals 1, we can substitute it back in. We can substitute it back into either one, but it's going to make sense to substitute it back into the simplest one. Y is going to equal 2 minus 1, which is 1. And that would be how I'd leave my solution. They go together as a pair. If you're doing it geometrically, you might even write down the coordinate 1, 1. And that's what we've just found here. And then the other solution, when x equals 3, we're going to get y is equal to 5, because it's 2 times 3, which is 6, minusing 1 to give me 5. And as you can see from the graph, I get that one as well. So I hope you're happy with this. The graph does solve this equation simultaneously. In this case, we can see where the solutions are, but you need to be able to do it algebraically. The graph also illustrates why this process works, why that we can set the y values equal to one another. All right, I want you to have a go at this one yourselves now. No graph, just think about the process we've just spoken about, give it your best shot. Right, in the same way as previous, we can set the y values equal to one another. X squared plus 5x minus 2 equals x plus 3. This time round, I've already got the x squared on the left-hand side, so that's great. I just need to set it equal to 0. So I'm going to minus x from both sides, and I'm going to minus 3 from both sides. And now it's equal to 0. We're back where we were in our starter. We're going to get x. How are we going to get a minus 5? When we times them, and a plus 4 when we add them. Well, the only way that it would factorize would be if I had a 5 and a 1. And I can see if I do plus 5 and minus 1, then it will work. And we're going to get x equals minus 5 or 1. And now my recommendation is to just deal with it one at a time. When x equals minus 5, y is going to equal, and again, substitute it back into the simplest one, this one here, minus 5 plus 3, which is minus 2. And then when x equals 1, y is a bit easier, just with the 1, y is going to equal 4. And we're done. It's that quick. There's a lot of steps, that's the thing. But if we understand the process, the fact that we're finding where, again, two graphs intersect, I'm not sure if these graphs are exactly right, but we tend to get two solutions. There are some instances when you don't get two solutions. That's more of an A-level topic, to be honest. Let's expect to get two solutions, and you can see it's where they intersect. Let's just find out them carefully. Well done. One more to try. Pause video, give this your best shot. Right, this is nearly the same, but there's two things we just need to take into account. The fact that it says solve giving your answers to 3 significant figures. This is actually code for quadratic formula. It means that you're not going to get a nice whole number answer. You're going to have to use the quadratic formula when you get to the part where you're solving a quadratic. And the second difference is that I've got a minus x squared going on. So I don't know exactly what it's going to look like, but let's say it might look a bit like this. Okay, that's what the shape of a minus quadratic is. This is a sad quadratic, and then 3x minus 8 might look a bit like this. And I'm going to get I don't know, it's not going to go through there, but it's going to be, there or thereabouts, something going on like this. Okay, but let's not stress about that. We can still solve it in exactly the same kind of way. Set the y values equal to one another. Now, my strong recommendation is don't try and deal with it with a minus x squared. Add minus x squared to both sides. Sorry, add x squared to both sides. And suddenly it's going to turn into this. X squared plus 3x minus 8 equals minus 2x minus 4. And now deal with the rest of it. You could have dealt with it all in one go, but don't rush it. Okay, and then we've got this one to solve. Now you can try and factorize it. Like if you didn't read this carefully, you might try to factorize it, but guess what? It won't factorize nicely. And what this equation is actually one that we've already looked at right at the start. It's this one here. X squared plus 5x minus 4. And I've actually already worked out the solution. I'm not going to go through all that process again because we've practiced it. You need to keep practicing it, but I have illustrated it already. So I'm nearly there. I'm going to get, okay, quadratic formula. See above. I've already gone through it in detail. Right, so then it's just a case of substituting these back in. Now the only thing I've not done is because I've rounded these to 3 significant figures, I've lost my extra figures. and I'd have to work them all out again, because I shouldn't just deal with this 0.702, because I'm going to be multiplying it by 3 and then minusing 8. But once I've done that, I can just substitute it in, and this is what you get as your final answer. So I'm writing it as coordinates here as well. Actually, it does say just solve the equations. It doesn't say like find the coordinates of intersection. Actually, this is how I should write it. I should write when x equals 0.702, y equals 5.89. When x equals minus 5.70, y equals 25.1. And those would be the points of intersection that I actually get. But just to say again, this is exactly the same process as previous. I just have to do a little bit extra to get the x squared on the other side, and then I use the quadratic formula. You'll get a mixture of questions now to try. I'm going to show you them actually. So you can pause the video. I'm gonna upload this as a handout. But this is the exercise I'd now like to try. I'd like to focus on questions 1 to 8, because these are all like the ones we've done today. The ones that we're going to look at next lesson are then 9 to 16, and you can see why these are slightly different, because they no longer have y equals. But that's for another time. If you do manage to get through 1 and 8 with time to spare, then you can feel free to have a look at them. Otherwise, focus on 1 to 8. And I'm now just going to show you the answers as well. The answers to 1 to 8 are here. It does say in the question, give your answers to correct to 2 significant figures where appropriate. So some of them will factorize and some of them won't. Well done. Keep practicing.